Hey guys, welcome back to my YouTube channel. So under this lesson, we are going to continue from where we stopped in the previous chapter. That's we are going to look at how to define the formula of a given sequence. Now let's move straight into the video. So we have a sequence which is 1 over 2, 1 over 4, 1 over 8, 1 over 16. And we are being told to define the formula for this sequence. Now, if you remember in the previous video, I said anytime you want to define the formula of a sequence, the first thing you are supposed to do is to check which type of sequence you are going to be dealing with. So you could check whether this sequence could be an arithmetic progression, a geometric progression, or the uncommon type that we normally meet, which is the exponential with progression. So how do you know that this sequence is an arithmetic progression? Now we said anytime you have a constant difference when you subtract the first term from the second term. So let's try and see something. So we realize for the first term, of course, since the numerators are the same, we would have to consider the denominators. Now here is going to be 1. Now when you subtract 1 from 2, you are going to get 1. When you subtract 2 from 4, you are going to get 2. When you subtract 4 from 8, you are going to get 4. So you realize you realize the difference is not going to be what's the same. So what do? Since the differences are not the same, it means the arithmetic progression formula is not going to work for us. So we now have to go to the geometric aspect. What does geometric says? It says you try and divide the term by themselves. So you take the first term, you divide by the second, and so on and so forth. If you realize that the ratio you are getting is the same, then it means you can easily use your geometric progression. So let's try that. 2 divided by 1, we are going to get 2. 4 divided by 2, we are going to get 2. 8 divided by 4, we are going to get 2. 16 divided by 8, we are also going to get 2. So we realize that with this one, we are having a constant ratio. So we can use the formula ARN minus what? Minus 1. Where A over here is our first term, R is the constant ratio we are getting. The ratio is the output you are getting after every division. So you realize we are getting 2, 2, 2, 2, 2. So yes, our R is going to be 2. And N is going to stay the same since we are looking for the nth term. And we just substitute the rest into the formula. So let's say our A sub N, which is going to be the sequence, our numerator is going to remain the same. But for our denominator aspect, what do? Now the first term, because we realize our denominator aspect is a geometric progression. So we just use the formula and substitute whatever values that we have. Very, very, very simple. So the first term is going to be 1, in which is not very necessary to write. Our constant ratio is going to be 2. Very good. And we have our n, then we have our what? Our 1. Now this is going to be the formula for this sequence. Very, very simple. Okay, so you can either maintain your final answer like this, or you can decide to rewrite it as 1 over 2 all raised to the power n minus 1. Now, why are we doing this? Now, we know that anytime we raise 1 to any certain power, the value of the numerator is not going to what? Change. Yes, so you can either write it like this or you can write it like this. Anyhow, you are still going to get the correct answer. Now, let's look at the second example. Now, the same thing, we are trying to define the formula for this sequence. So, as usual, you realize the numerator is not changing, right? The numerator is remaining constant, so we will not have any problem over there. It's the denominators that are changing. So we would have to look at how the denominators are moving and we'll know how to tackle this problem. So as usual, anytime you have a sequence, you do your 3 checks, right? You check whether it's an arithmetic progression, a geometric progression, or something different from those two. So when we do our arithmetic progression, we realize that the differences over here are not the same. Since 3 minus 1 is going to give us 2, 6 minus 3 is going to give us 3, 10 minus 6 is going to give us 4, 15 minus 10 is also going to give us 5, which means arithmetic formula is not going to work over here. So what do? We try the geometric formula. Now, when you try the geometric formula, what do you think is going to happen? Now, 3 divided by 1 is 3. 6 divided by 3 is 2. 10 divided by 6, of course, you would get a fraction or a decimal. So you realize that the ratio over here is not constant as well, which means we can't use arithmetic progression. We can't also use the geometric progression. When this type of situation happens, what do? You can check whether this is going to be an exponential progression. Now, how do you do that? It's very, very, very simple. The first thing you are supposed to do is to what? Find the first and second difference. What do I mean by that? So you know that your denominator is going to be 1, 3, 6, 10, and 15. Now, anytime you realize you can't get a geometric or an arithmetic progression out of it, you can do something we call the exponential progression test. That's finding the second difference of the sequence that we are having. So let's find the first difference. So when you take the first difference, what do we have? 3 minus 1 is what? Is 2. 6 minus 3 is 3. 10 minus 6 is 4. 15 minus 10 is 5. Yes. Yes. So this is the first difference. You realize that the differences are not the same. So what do? You take the second difference again. You try to take the second difference. Now, 3 minus 2 is going to give you what? 1. 4 minus 3 is going to give you 1. 5 minus 4 is also going to give you 1. So you realize that with this problem, we had the same or constant difference when we did the second subtraction. So when we did the first subtraction, we were getting values that were not the same. But when we did the second subtraction, we had the same what values, which means this is going to be an exponential progression since we are having it in the second what difference. So how do you go about it? Now we know that since we are facing an exponential progression, we have to use the exponential formula, which is an squared plus bn plus c, which is going to be equal to 0. Now this is going to be the expression which is going to help us find the formula for this sequence. What do we do next? Now, as you can see, we are trying to find the nth term of this sequence. So which means we are obviously supposed to find a, b, and c. Now, you know that you are having 3 variables to find. Since you are having 3 variables to find, all you also need is just 3 terms from the actual sequence to help you find those 3 variables. So the first thing you can easily do is to what? Just write your a, put your bracket squared plus b, wherever you see n, you put a bracket plus c, which is equal to the first term, which is what? 1. Because we are trying to substitute 1 into the what? The function to give us an output. So wherever you have 1, what are you supposed to get? You are supposed to get 1. Wherever you have 2, you are supposed to get 3. Wherever you have 3, you are also supposed to get what? 6. So the same thing. You remember we need 3 expressions. So the same thing over here, plus b, bring your gap, and what? And c. And you know that when n is equal to 2, your final output is going to be what? 3. Then you try for the last one because we need 3 expressions. Now you bring your a, you have your squared, b also, you have this plus c, which is supposed to give us 6. Now, for the first one, when n is 1, you put 1 into the bracket. When n is 2, you put 2 into the bracket. When n is 3, you put what? 3 into the bracket. Now, all you are going to do is to just simplify these expressions. So, we are going to get a plus b plus c, which is equal to 1. Then we get 4a plus 2b plus c, which is equal to 3. Then the final one, we have what? 9a plus 3b plus c, which is equal to 6, because we are trying to simplify. 3 squared is 9, 2 squared is 4, and so on. So after doing this, now you realize we are having a quadratic type of expression in which we simplified it to get simultaneous what equation. So we are now having 3 variables and we are trying to find the values of a, b, c. So to prevent time wastage, you can easily use your calculator to solve for this simultaneous equation. Yes, so this is my calculator. Now, I hope you guys are following. So, what are we trying to do? We are having three variables A, B, C, which means a three simultaneous equation. We are trying to find A, B, and C, so we can use it to find our N. So, all you just have to do is on your calculator, press mode, equation, and look for the expression that says you are trying to find a simultaneous equation, and you are going to get 2. Very good. So what do you do? All you just have to do is input the values into the calculator. So you have 1, you have 1, you have 1, and you have 1 as your what? Your first expression. Now when you go to the second one, you have 4, you have 2, you have 1, and you have 3. Now when you go to the last one, you have 9, you have 3, and you have what? 1. And your final answer is going to be 6. So after punching this into the calculator, you realize that the first value we are getting, it says what? X. Now since we are using what? Three variables in the calculator, we are going to get x, y, z. So it's saying that our x is going to be equal to half, which means our a is going to be equal to half. And when you check to, our b is also going to be equal to half. So our b is also going to be equal to half. And finally, when you check for c, yes, c is equal to 0. C is equal to 0. So what do you do now? After calculating for your A, B, and C, all you are going to do is to substitute it into the actual quadratic formula or exponential formula. So you know that this is the formula. We have what? AN squared plus BN plus C, which is equal to what? 0. Now, you know that A is equal to half n squared plus B is also equal to half n plus C is 0, which is obviously going to be equal to what? 0. So you realize that from here, from this place, you can easily what? Simplify. From this place, you can easily simplify. Now over here, you are going to get n squared plus n all over 2. You are going to get n squared plus n all over 2. And you can further break it down to get n having what? N plus 1 all over what? Over 2. So which means this is going to be the what? The formula for the denominator, but not for the actual sequence. But this is going to be the formula for the denominator. So let's try and see something. Let's say when n is 1, so you are going to get 1, and you're also going to get 1 plus 1, which is 2. 2, 1, 2. When you divide 2 by 2, you are going to get what? 1. When n is 2, you are going to get 2, 2. So 2 plus 1 is 3. 3 to 6. When you divide by 2, you're also going to get 3. So now let us rewrite it. So in rewriting it, we know that our numerator is going to be what? 10 all over n bracket open n plus 1 all over 2. Now with the knowledge and a fraction, you can easily simplify this. So you know that with this one, we are going to get what? 10 multiplying 2 all over n bracket open n plus 1. So at the end of the day, what are we going to get? We are going to get 10 or no 20 all over n bracket open n plus 1. And this is going to be the formula for the sequence. This is going to be the formula for the sequence. So now let us do some try test. This is first term, second term, third term, fourth term, and fifth term. Let us try and prove for for the fifth term. So when n is equal to 5, what are we going to get? So let's see. We are going to get 20 all over 5, 5 plus 1. Now, when you solve this one, you are going to get 20 all over 5, 1, 5, 5 plus 1 is what? Is 6. So it's 5, 6, 30. You are going to get what? 30 over here. So you realize that since we are trying to maintain this value, we don't have to necessarily break this fraction into its simplest form. Rather, we want to break this fraction down to get something like this. So you know that when you divide 20 by 2, you are going to get 10. And when you divide 30 by 2 also, you are going to get what? 15, which is going to give you the what? The fifth term.